Our programs offer many languages. Please visit suprememastertv.com/schedule.
Thanks to the team's labour of love, Seymour can now happily dive like a normal turtle with their 3D printed backpack. Please continue watching to find out more.
Hola, amorosos televidentes, means hello, lovely viewers, in Spanish, one of the official languages of Bolivia. I am Arturo, a vegan toco toucan from the Verdun Aquicuana Municipal Reserve in northern Bolivia. The animals and people of my aspiring nation wish that you experience the bountiful blessings of nature wherever you are. Welcome to 3D Printing Technology, Working Wonders for Animals, Part 2 of 2. In the previous episode, we explained how wonderful 3D printing technology has given animals with certain serious diseases or injuries a new lease of life. In today's program, I will introduce more touching stories about how 3D printing helps animals and the innovative 3D bioprinting technologies that could help hasten the end of the vile practice of animal testing in the future. In 2009, Seymour the green sea turtle was hit by a boat propeller in the Florida Keys. Her shell and spine were damaged, which meant air accumulated in her lower intestines. As a result, Seymour could only swim with her rear end sticking up and her head down. This hindered her ability to dive normally to find food in the wild, and she could no longer live independently. A rehab hospital in Florida sent her to the care team at Sea Life Minnesota Aquarium in Minnesota, USA, where Seymour now resides. At first, the team had used epoxy to glue counterbalance weights to the shell to correct her buoyancy. However, the weights would fall off when Seymour naturally shed plates on her shell or scutes, and replacing the weights was stressful for the turtle. To design a permanent solution for Seymour, Trainer Knott of Sea Life reached out to a group of University of Minnesota engineering students for assistance. It was not an easy mission as there were limited angles to place a prosthesis on the giant turtle's back for a start. The solution needed to withstand salt water while allowing water to flow around it freely. Plus, it had to remain intact while interacting with other sea animals. The group decided to use 3D printing, a cost-effective solution that allowed them to compare different proposals, readjust the design, and produce and test prototypes. After a computed tomography or CT scan in July 2017, the team examined Seymour's shell structure and the damage, and then selected the exoshell design. The Considerate project team attached the 3D printed prototypes to Seymour's shell using Velcro during the testing process. So the prototypes could be easily removed, adjusted, or reattached without moving Seymour out of her tank. Thanks to the team's labor of love and Trainer Knott's loving care around the clock, Seymour can now happily dive like a normal turtle with her 3D printed backpack. What a heartwarming remedy for a deserving sea turtle! Yellow Purple is a 23-year-old African penguin at the Mystic Aquarium in Connecticut, USA. After tearing a flexor tendon in her left leg in 2011, she could not walk properly. The vets at Mystic Aquarium tried to help her by designing a handmade plastic boot, but the material deteriorated fast and required frequent replacements. Additionally, the boot was inflexible and heavy, limiting the penguin's movements. In 2016, after hearing the potential of the emerging 3D printing field, the caring team decided to seek a partnership with the local Mystic Middle School, which had just received its first 3D printing system to familiarize students with this technology. The students were ecstatic to be allowed to design a 3D printed orthotic boot for Yellow Purple, and the 3D printer manufacturer and one of its vendors participated in the project to give the students technical guidance during the course of the work. The students scanned a cast of the penguin's injured foot, generated a digital model, added details with 3D sculpting software, and finally created the boot using a multi-material 3D printer. The single-piece boot was made from both flexible and rigid materials, making it durable, elastic, and lightweight. As soon as the penguin was fitted with her new 3D printed boot, she immediately took off across the exam room. It was a very exhilarating and inspiring moment for the students who participated in the project to see a member of an endangered species be filled with joy. Sadie, a Mystic Middle School student, said, "When I saw her just walking with the boot that we all designed, it made me feel very happy to see this working. Now, Yellow Purple can walk and swim like normal penguins do. Congratulations to all involved!" Let's pause here briefly for a constructive message and then we'll return. Please stay tuned to Supreme Master Television. Welcome back to 3D Printing Technologies, Working Wonders for Animals, Part 2 of 2. Many new cosmetics, drugs, vaccines, and other products are often tested on animal models to determine their supposed efficacy and safety before human trials or being released into the market. In the US, more than 100 million animals are harmed by this cruel, barbaric, and ineffective testing annually. According to the US National Institute of Health, 95% of drugs that supposedly test as effective and safe in animals eventually fail in human clinical trials. And within the small percentage of drugs approved for human use, half end up with side effects not identified in animal tests. There have been increasing protests against the unethical, inhumane, and useless practice of animal testing in recent years. And compassionate scientists are responding with an eye-opening alternative, 3D bioprinting. Three-dimensional bioprinting means creating biomedical parts that imitate natural tissues, such as heart or skin tissues, using additive manufacturing. In the typical bioprinting process, the requisite human cells are cultivated into a bioink, which is a microgel containing oxygen, water, and nutrients for the cells to stay alive. Scaffolding materials for cells to grow on and develop into three-dimensional tissues are used. Next, the 3D bioprinter deposits the bioink loaded in its cartridge, layer by layer, based on the digital model of the target tissue derived from CT or magnetic resonance imaging or MRI scans. Then, the printed pre-tissue layers are transferred to a bioreactor where optimal chemical stimulations or UV exposures are applied to solidify and cross-link the layers to generate the final product. Although still in the infancy stage, 3D bioprinting technologies have achieved outstanding initial success. Since the EU banned animal testing in cosmetics products in 2009, bioprinting human skin tissues for cosmetics testing has become the primary area of interest. Human skin tissues can be bioprinted with blood vessels, pigmentation, sweat glands, hair follicles, and immune macrophages, and hence strongly resemble real tissues. In addition to skin tissues, other biocompatible human tissues can also be bioprinted. For example, bioprinted human liver tissues can exert drug and glucose metabolism functions, making them suitable for new drug development. Moreover, fast-advancing organ-on-a-chip technology allows cells that recap the architectures and processes of human organs to live inside translucent tiny computer chips. The chips are interlinked with live human cells, and mechanical forces can be applied to simulate microenvironments of organs, such as breathing and blood flow motions. Additionally, the transparency of the chips provides a window to study the inner activities of human organs. The organ-on-a-chip technology has the advantages of rapid response and precision control. Hence, researchers can test new medicine cheaper and quicker than animal models. Furthermore, the latest volumetric bioprinting technology is promising. It uses cell-friendly visible laser lights to cast multiple CT projections simultaneously onto a light-sensitive microgel container, so organs with complex, convoluted geometries could one day be printed in tens of seconds using a 3D laser light field, instead of hours or days required by the conventional layer-by-layer printing method. The amazing 3D printing technology is truly working wonders for animals. Custom-made and fitting implants, prosthetics, and orthotics have given many seriously injured animals a new lease on life, and precise, realistic surgical models have significantly reduced animal surgery risks. On the other hand, the cool and creative 3D bioprinting technologies have great potential to save countless animal lives as researchers turn away from animal testing. May these life-saving technologies rapidly become more efficient and cheaper to benefit more animals, in God's blessings. Esteemed viewers, thank you for your company today for our program. Up next is Knowing Yourself Through Diligent Questing, Part 7 of 7, on Between Master and Disciples, right after noteworthy news. May your kindness return to you in the same beautiful way it was offered.
Our programs offer many languages. Please visit suprememastertv.com/schedule and suprememastertv.com/AW.
Nos programmes offrent plusieurs langues. Veuillez visiter suprememastertv.com/schedule et suprememastertv.com/AW.
Nuestros programas ofrecen varios idiomas. Visiten suprememastertv.com/schedule и suprememastertv.com/AW.
Манай нэвтрүүлгүүд олон хэлээр гардаг. Зачлах хаяг suprememastertv.com/schedule болон suprememastertv.com/AW